Okay, so here's an example of a table integral where it's a power reducing type of integral formula, right? Almost like a recursion kind of formula here where uh, the table integral itself has the result is another integral, right? And we'll take a look at how we use that to evaluate something like this, x cubed, the integral of x cubed e to the 2x dx. Right, now I looked this up in my table, and this is the result that it gives me, right? So for my particular example here, a is 3, n is 3, and my a is 2. Right, so when we do that, okay, so that'll be 1/2, right? X is my u here, x cubed, e to the 2x, and then minus x over a, n over a, so 3 over 2, and then the resulting integral is x n minus 1 squared and e to the 2x as is dx. Okay, and then what you see here is, well, we're not done yet, right? We still need to go further, and we need to apply this formula again, right? In my next iteration here, right, I'm going to have here n is going to be 2 and a is also 2. Right, so then here this stuff remains the same, right? It's still 1/2 x cubed e to the 2x minus 3 over 2, and then just careful with signs here. And then I reuse the formula again, now with a being still 2, so 1/2, and now my n is 2, so we get x squared e to the 2x minus n over a, in this case is 1, and then the integral of, now we drop it down by a power, e to the x, x to the first power and e to the 2x dx. All right, and again, right, we can still go further here, right, where now n is 1 and my a is still 2, right? So these other parts remain the same. I'm going to need more space here. So we get 1/2 x cubed e to the 2x minus 3/2 1/2 x squared minus e to the 2x minus, open another set of brackets here, n is 1, so you're going back to my formula, so we just get 1/2 here for the coefficient u, in this case x squared e to the 2x. All right, so 1/2 x e to the 2x minus n over a, so that's 1/2. The integral, now we get n, 1 minus 1 is 0, so x to the 0 is just 1, and we get e to the 2x dx. All right, and now notice here that here we no longer need the formula up top because it's not of that type. We have gotten rid of, there's no more x, right? And we just now, luckily, we have a straightforward integral, right? The integral of e to the 2x is e to the 2x, but don't forget about that factor of 2 divided by 2. So lastly, we get 1/2 x cubed e to the 2x minus 3/2 1/2. Okay, let me start dropping some parentheses here. So that's going to be minus 1/2 x e to the 2x, and then plus, careful with your coefficients here again, right? Just make sure you're keeping track of everything. When I integrate this, it's e to the 2x over 2. There's already a 1 over 2 on here. So the last result here, but 1/4 e to the 2x plus c. And now let me drop that last parenthesis here and really distribute that negative 3/2. So 1/2 x cubed e to the 2x minus 3/4. Oh, I dropped something here. Oh. 1/2 x squared e to the 2x. So 3/4 x squared e to the 2x plus 3/4 x e to the 2x minus, opposite sides, it's minus 3/2, minus 3/8 e to the 2x and plus c. All right, and that's the iteration of the power reducing formula until we're able to have a basic integral of my exponential function. All right. Now, maybe you're saying to yourself, you could have done it by parts. Yes, right, and that is kind of the purpose of this example here, is to notice that yes, the table is a tool that we can have, but what's important here is to focus on our own kind of techniques to develop, because if you notice here that this took a lot of effort to do this, right? And I was really simple. I just looked up the formula and then just plug away, right? And I just did that over and over, right? But if I understood kind of what the techniques that I've been going through and understood how to apply them, then something like this, right? I could say, all right, well, looking at that, I know I can just easily set up my differentiate integrate table here. X cubed e to the 2x, and then each step of the way, 2x over 2, 3x squared, and here we get e to the 2x over 4, 6x, one more, e to the 2x over 8, 6, and then lastly, e to the 2x over 16, and then 0. So plus, minus, plus, minus, plus, here, 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 here. Right? And then now multiply this through, and we get the first part is x cubed 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x, and plus 6 over 8 reduces to 3/4, so plus 3/4 x e to the 2x, and then minus the last one here, 6 over 16 is 3/8 e to the 2x. Right? And notice here, of course, the plus c. And notice here, this is exactly what I got by using that table integral. All right, and again, by first just understanding, right, the technique, right, how I can evaluate this, and it took me a lot less time, right.